This video will cover beginner questions part 2 regarding the topic of integration by partial fractions. Question 1. Because x cubed minus 4x is x times x squared minus 4. Use the formula a squared minus b squared equals a plus b times a minus b. Then back to the original, x times x squared minus 2 squared, that means x plus 2 times x minus 2. Since the denominator has 3 distinct linear factors, the partial fraction decomposition of the integrand has the form x squared plus 12x plus 12 over the denominator x times x plus 2 times x minus 2 equals a over x plus b over x plus 2 plus c over x minus 2. To determine the values of a, b, and c, multiplying by the least common denominator, which is x times x plus 2 times x minus 2 on each side. Now we have the basic equation x squared plus 12x plus 12 equals a times x is cancelled, then x plus 2 times x minus 2 plus b times x plus 2 is cancelled, then x minus 2 plus the last one c times x plus 2 times x minus 2 is cancelled. To solve for a, let x equal 0, 0 squared 0 plus 0 plus 12 is a times 0 plus 2 times 0 minus 2 plus this is 0 plus another 0. Then 12 is 8 times minus 4. Then a is minus 3. To solve for b, let x equal minus 2. Then minus 2 squared is 4. Plus 12 times minus 2 is minus 24. Plus 12 is 8 times minus 2 plus 2 is cancelled, then 0. Plus b times minus 2 times minus 2 is minus 4. Plus minus 2 plus 2 is 0. Then minus 8 is 8b. Then b equals minus 1. To solve for c, let x is 2. Then 2 squared is 4. Plus 12 times 2 is 24. Plus 12 equals 2 minus 2 is 0. Plus 2 minus 2 is 0. Plus c times 2 plus 2 is 4. Then this part is 40 equals 8c. Then c is 5. Now we have a is minus 3, b is minus 1, then c is 5. So it follows that the integral x squared plus 12x plus 12 over x times x plus 2 times x minus 2 dx equals integral a over x minus 3 over x plus b over x plus 2 minus 1 over x plus 2 c over x minus 2 5 over x minus 2 dx. Then the final answer is minus 3 at an absolute value of x minus at an absolute value of x plus 2 plus 5 at an absolute value of x minus 2 plus c. Question 2. Since the degree of the numerator is greater than the degree of the denominator, we need to do wrong division. The numerator x cubed plus 0 x squared minus x plus 3 divided by the denominator, which is x squared plus x minus 2. The first one is x times x squared is x cubed plus x times x is x squared. Then x times minus 2 is minus 2x. Minus cancelled. 0 minus x squared is minus x squared. Minus x plus 2x is plus x. Then plus 3. Then minus 1. Minus 1 times x squared is minus x squared. Minus x. Then plus 2. Then cancelled. X plus x is 2x. 3 minus 2 is plus 1. Using the division algorithm, we can rewrite as x cubed minus x plus 3 equals x minus 1 times x squared plus x minus 2 plus the remainder 2x plus 1 divided by x squared plus x minus 2 on each side equals, first one is cancelled, then x minus 1 plus the second one is 2x plus 1 over x squared plus x minus 2. Now we have x cubed minus x plus 3 over x squared plus x minus 2 equals x minus 1 plus 2x plus 1 over x squared plus x minus 2. Now let's make this part a partial fraction. 2x plus 1 over, we can factor the denominator x squared plus x minus 2. X plus 2 times x minus 1. The partial fraction decomposition form is a over x plus 2 plus b over x minus 1. Multiplying by the least common denominator, which is x plus 2 times x minus 1 on each side. Then the first one is 2x plus 1 equals a times x plus 2 is cancelled, then x minus 1 plus b times x minus 1 is cancelled, x plus 2. To solve for a, if x is minus 2, then minus 4 plus 1 is a times minus 2 minus 1 plus minus 2 plus 2 is 0. And minus 3 is minus 3a, then a equals 1. To solve for b, if a is 1, then 2 times 1 plus 1 is 1 minus 1 is 0, plus b times 1 plus 2 is 3. Then 3 equals 3b. Then b is 1. Finally, we can conclude that the integral of x cubed minus x plus 3 over x squared plus x minus 2 dx equals integral of x minus 1 plus a over x plus 2, a is 1, then 1 over x plus 2 plus b over x minus 1, b is 1, 1 over x minus 1 dx equals x squared over 2 minus x plus ln absolute value of x plus 2 plus ln absolute value of x minus 1 plus c. Question 3. Since the degree of the numerator is less than the degree of the denominator, we don't need to divide. We factor the denominator as x cubed plus x squared minus x minus 1 equals, factor the first two terms, take out the common factor x squared, then times x plus 1. Now factor the last two terms, take out the common factor minus 1, then times x plus 1 equals, now x plus 1 is the common factor, so we can factor x plus 1 times x squared minus 1, but we have to factor completely x plus 1 times x squared minus 1 is x plus 1 times x minus 1. Use the formula a squared minus b squared is a plus b times a minus b. Then the final answer is x plus 1 squared times x minus 1. Since the linear factor x plus 1 occurs twice, the partial fraction decomposition is 4x squared over x plus 1 squared times x minus 1 is a over x plus 1 plus b over x plus 1 squared plus c over x minus 1. Multiplying by the least common denominator x plus 1 squared times x minus 1 or x squared equals x plus 1 is cancelled, then a times x plus 1 times x minus 1 plus b times x plus 1 squared is cancelled, then x minus 1 plus c times x plus 1 squared, x minus 1 is cancelled. Now we get the basic equation. To solve for b, if x is minus 1, then 4 times minus 1 squared is 1 equals 8 times minus 1 plus 1 is 0 plus b times minus 1 is minus 2 plus c times minus 1 plus 1 is 0 squared is also 0. Then 4 equals minus 2b. Then b is minus 2. To solve for c, if x equals 1, then 4 times 1 squared is 4 equals 1 minus 1 is 0 plus 1 minus 1 is 0. Then c times 1 plus 1 is 2. Then 2 squared is 4. Then 4 is 4c. then c equals 1. In the basic equation so far, the value of x has been inserted to eliminate the term, whether x equals 1 or minus 1, the term with a is erased. So find the most convenient number. To solve for a, we use x equals 0. So if x is 0, then 4 times 0 is 0 equals 8 times 0 plus 1 is 1, 0 minus 1 is minus 1, plus b is already found minus 2, then 0 minus 1 is minus 1, plus c is 1, then 0 plus 1 square is 1. Then 0 equals minus a plus 2 plus 1, then a equals 3. So it follows that the integral of 4x squared over x plus 1 squared times x minus 1 dx equals the integral of a over x plus 1, a is 3 over x plus 1, b over x plus 1 squared, b is minus 2 over x plus 1 squared, plus the last one, c over x minus 1, c is 1, then 1 over x minus 1 dx is 3 times at an absolute value of x plus 1. The second one, use the substitution, minus 2 integral 1 over x plus 1 squared dx. Let u is x plus 1, then divide on each side, du equals dx, minus 2 times integral of 1 over u squared dx is du, is minus 2 times integral of u to the power of minus 2 du, then minus 2 times u to the power of minus 1 over minus 1 plus c, cancelled, then 2 over u plus c, then 2 times u was x plus 1 plus c. Then back to the original, plus 2 over x plus 1 plus the last one is at an absolute value of x minus 1 plus c. Question 4. We can factor the denominator using the difference between 2 cubed. Use a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So x cubed minus a, which is 2 cubed, equals, now a part is x, b part is 2, then x minus 2 times x squared plus 2x plus 4. It contains irreducible factors for none of which are repeated. We write 6x over x minus 2 times x squared plus 2x plus 4 equals a over x minus 2 plus bx plus c over x squared plus 2x plus 4. Multiplying by the least common denominator, x minus 2 times x squared plus 2x plus 4, then 6x equals 8 times x minus 2 is cancelled, then x squared plus 2x plus 4 plus bx plus c times, this one is cancelled, then x minus 2. To solve for a, if x is 2, then 6 times 2 is 12, equals a times 2 squared is 4, plus 2 times 2 is 4, plus 4, plus 2 minus 2 is 0. Then 12 equals 12a, then a equals 1. To solve for c, if x equals 0, then 6 times 0 is 0, equals a times 0 plus 0 plus 4, plus b times 0 is 0, then c times 0 minus 2 is minus 2, then 0 equals a is 1, then 4 minus 2c, then c equals 2. To solve for b, if x is 1, then 6 times 1 is 6, equals a, which is 1, times 1 squared, plus 2 times 1, plus 4, plus b times 1 is b, plus c is 2, times 1 minus 2 is minus 1. Then 6 equals 7 minus b minus 2. Then 6 equals 5 minus b. Then b equals minus 1. So it follows that the integral of 6x over x minus 2 times x squared plus 2x plus 4 dx equals the integral of a over x minus 2, a is 1, then 1 over x minus 2 plus bx plus c, then b is minus 1, then minus 1x, c is 2, over x squared plus 2x plus 4 dx. Here we break the integrand into two parts. Integral of 1 over x minus 2 dx. The numerator we can rewrite as minus x minus 2, then minus integral of x minus 2 over x squared plus 2x plus 4 dx. So far, the role of partial fraction is over. From now on, the point is how well you remember the integral of the inverse trigonometric function you have already learned. Now, let's integrate only the inverse trigonometric function part separately. We have to think about what du is first, so use U substitution. Let u equal x squared plus 2x plus 4, then du is 2x plus 2 dx, then du equals, take out 2, then x plus 1 dx, then divide by 2 on each side, du over 2 equals x plus 1 dx. We need x plus 1 dx, so plus 3 minus 3 here, it is equal to plus 0, so we can rewrite as the integral of x plus 1 minus 3 over x squared plus 2x plus 4 dx. Then divide into two fractions. The first one, integral of x plus 1 over x squared plus 2x plus 4 dx minus the second one is 3 over x squared plus 2x plus 4 dx. Of course, the first integral is to use U substitution. The integral of the denominator part is U, then x plus 1 dx is 1 over 2, then du, minus the second integral involves arctangent. We can write the denominator as a sum of two squares. Make x squared plus ax, completing the square. Then a divided by 2, then squared, equals x plus a over 2 squared. So the denominator x squared plus 2x plus 4 equals x squared plus 2x, then 2 divided by 2 is 1, 1 squared is 1, then the leftover is 3, then x plus 1 squared plus 3. Then back to the original, the integral of 3 over x plus 1 squared plus 3 dx equals 1 over 2. Integral of 1 over u is ln absolute value of u minus use the substitution. Let w is x plus 1, then dw equals dx. So this part is integral of 3 over w squared plus 3 dw. Now use the formula. Integral 1 over a squared plus u squared du equals 1 over a arctangent of u over a plus c. Then in here a squared is 3, that means a is square root of 3. Then back to the original, 3 times 1 over a is square root of 3, then 1 over square root of 3 arctangent of u means w over a means square root of 3 plus c equals 1 over 2 ln absolute value of u was x squared plus 2x plus 4 minus 3 over square root of 3 is square root of 3 arctangent of w was x plus 1 over square root of 3 plus c. And in here, x squared plus 2x plus 4 is always greater than 0. So we don't need absolute value sign. The bracket is okay. Now we have the integral of x minus 2 over x squared plus 2x plus 4 dx is 1 over 2 ln bracket x squared plus 2x plus 4 minus square root of 3 arctangent of x plus 1 over square root of 3 plus c. Now back to the original. Remember what I did on the previous page. Then the first one is ln absolute value of x minus 2 minus, the bracket is open, this one is the whole thing, the 1 over 2 ln bracket x squared plus 2x plus 4 minus the square root of 3 arctangent x plus 1 over square root of 3 plus c. Then final answer is ln absolute value of x minus 2 minus 1 over 2 ln bracket x squared plus 2x plus 4. The second one plus the square root of 3 arctangent of x plus 1 over square root of 3 plus c. If the integral of the inverse trigonometric function right now is too fast or you don't understand it well, take a look at the integration inverse trigonometric functions in the playlist. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.